Okay, welcome back. Today we are going to review dividing square roots, which another way to say it is radicals. So dividing radicals. And then I have just like a little description here. If you have two square roots that are being divided, then you can write them as a single square root and move the division inside the square root. And I'll kind of show you exactly what that means on a couple of these. So let's get started. So we're going to simplify, rationalize the denominator when necessary. So I thought we would start with one of those since rationalizing sometimes we forget about. So the first one's just 1 divided by the square root of 5. So you cannot leave a radical in the denominator. It's kind of like one of those irrational, undefined pieces. So we have to rationalize this denominator in order to make that just a regular 5. So to do that, I'm going to multiply the top and the bottom of this fraction by the square root of 5. So I get 1 times the square root of 5, which is just the square root of 5, over, now the square root of 5 times itself is going to be the square root of 25. So I'll kind of show my work along the way here. But we all know that 25 is a perfect square. So to simplify this all the way, that would just become 5. So the square root of 5 over 5. So you don't have to show this step right here. I typically just know when I multiply a radical times itself, that number under the radical is just going to come out, all by itself. Okay, now number 2, this is kind of what I was talking about up above here when I made that little comment about the two square roots being divided. So this one, see how it's the square root of 10 over the square root of 5 from the start. So I could have written that as the square root of 10 over 5. And again, you don't have to do that. Like if you understand that these two are the same thing, but then I can divide 10 by 5 and just get the square root of 2. And there's nothing more I can do with that. So even though we had the square root under there over the 5 in the denominator, initially we did not have to rationalize because the 10 in the 5 could be reduced. So you kind of want to reduce it as much as you can before you even consider rationalizing, because sometimes you can kind of get out of it and you won't have to do that step. Okay, so this one here looks similar to number 2. So if I were to write that into all one big radical, be 6/54ths, and that reduces to the square root. I'm just going to reduce that fraction. It'd be the square root of 1 over 9. Now I'm going to go ahead and take the square root of 1, so that's a perfect square, which is 1, over the square root of 9, which is 3. Or you can look at it as the square root of 1/9 is going to be 1/3. And that is our simplest form answer. Now this one's kind of already written as one big fraction under the radical. So I'm going to divide 80 by 5. And that divides out evenly to be a 16. And then the square root of 16, we all know, is 4. So can't do anything else with that one. See, we've been kind of reducing, except for that first one, I've been reducing it, first because I can, and then I don't have to worry about rationalizing. All right, now number 5, kind of in a jam on this one because we can't really avoid having to rationalize this 2. Like there's nothing in the numerator that will simplify with any part of that. So I'm going to leave the 5 where it is. I'm just going to multiply top and bottom of this fraction by radical 2. And I'm going to multiply straight across. So 1 times radical 2 is just radical 2 over, okay, now be careful, this is a 5 here that's being multiplied. So I'm going to show all my steps. So that'd be 5 times the square root of 4. But remember, we just rationalized, so I know that square root of 4 is going to become a 2. And then you multiply the 2 by the 5. So then my final simplified answer is just a radical 2 on top over 10. So this square root of 4, we replace that with a 2, and then you're multiplying here. You're always multiplying when there's a number that's just sitting out in front of the radical. It's always a multiplication. And then we can't do anything else with that because you cannot simplify a number that's under the radical with a number that's not under the radical. Okay, so don't do anything with that 2/10. Okay, so I've got some busier ones coming up. So number 6, I am going to reduce the 27/9. And then I'm going to reduce the 490 divided by 5. So that's just going to become a 3. I'll go ahead and show 3 over 1. Now after I divide the 490 by 5, I'm still going to be under the radical. So that's going to be the square root of 98. Because 490 divided by 5 was 98. Now I really don't need that 1 there. I'm going to kind of let that go. It's just 3 square root of 98. Now a few lessons ago, a few videos ago, you guys probably learned how to simplify the square root of 98. Now the way I do it is I take and look for perfect squares. So like this one I would consider the largest perfect square that can go into 98 would be 49. So 49 times 2. Right, 49 times 2 is 98. And then I can take the square root of 49. Okay, that's going to be 7. Now when I do that, remember I have this 3 sitting out here that's being multiplied. So I'm going to take the 7 from the square root of 49 and I'm going to multiply it by the 3. So it's going to be 21 radical 2. And remember we had a 1 over here at the beginning. We really didn't have anything, so I kind of let that 1 go and I just dropped the denominator. Just kind of trying to give you a picture of every kind of type that I possibly can think of, because with radicals, there isn't one that's the same as the next. They just keep changing them up on you. So 27 over the square root of 18. So I can't simplify, right away because the 27 is not under the square root. So I'm going to simplify the 18 as much as I can. This is just the way I would prefer to do it. Oops. So that would be 9 times 2. 9 is my largest perfect square. So I'm going to go ahead and take the square root of the 9, which is 3, times the square root of 2. So I could take out the 3 from the 9, but I can't do anything with the 2 that's under the radical, so it just has to stay there. But now I'm kind of in a jam. I can't leave that there, so now I have to rationalize. Multiply top and bottom by radical 2. So I get 27 radical 2 all over. Now remember, this becomes the square root of 4. So really that's just 2, and then I multiply it by the 3. So this is the square root of 4. Oops. Yeah, I guess I'll leave it there. And then that's going to simplify to be a 2. So then all that's gone, and I'm just doing 3 times 2. Well, I can simplify one more thing. I have a lot of radical 2's here. I didn't even plan that. Interesting. I can divide both of these by 3. So I'll get 9 square root of 2 over 2. Now that's my final answer. That one was quite busy because I simplified the radical at the beginning, then I had to rationalize, then I had to simplify the fraction, this fraction, at the end. So you just got to kind of hang on until you get it, to its simplest form. Okay, I do have one more. Kind of got it on the side here. There we go. This one, again, 8 and 6. I'm not going to be able to simplify that because the 8's not under the radical. So I'm just going to rationalize it right from the beginning. So multiply top and bottom by radical 6. So I get 8 radical 6 all over, remember, square root of 36, which is 6. I'm just going to bring a 6 right out. Now, once again, check out your 8/6 because that's not quite finished yet. You can reduce that by 2. So you get 4 radical 6 over 3. Now I'm simplified. All right, see you later.